Okay, I am going to be doing some advanced examples of quadratic equations. Okay, advanced quadratic equations. All right, that's what we're going to be doing. I will assume that you have had prior instruction and an intermediate level of familiarity with reducing radicals, completing a square, and the quadratic formula. If you have not seen basic videos of this or had basic instruction in this recently, don't watch this video yet. Watch something more basic. Okay, so as this assumes prior recent instruction, in reducing radicals, completing a square, and the quadratic formula. Okay, on the assumption that you have it, I'm going to go ahead and add some advanced. I'm going to go ahead and begin advanced examples. Example 1. By the way, I'm going to go ahead and put the quadratic formula over here. All right, so example 1. Solve 5x squared minus 70x minus 130 equals 0 by completing the square. Okay? So what you're going to do here is you are going to divide that 5 that's common to all three of the terms. Sorry. Factor out that 5. That gives me x squared minus 14x minus 26 equals 0. Then you'll divide it off. So x squared minus 14x minus 26 is 0. Now to complete the square, you have to isolate the x terms. So we'll be adding 26. So x squared minus 14x equals 26. Next, you're going to be taking something and dividing it by 2. That something is a negative 14. Negative 7 squared is 49, which we add to both sides. So that's going to give me x squared minus 14x plus 49 equals 26 plus 49. Okay, add the 49, add the 49. Okay? So that's going to give me x minus 7, x minus 7 equals 75. So that gives me x minus 7 squared is 75. Always reduce the radical before you do anything else. So we have x, well, we'll deal with this. X minus 7 equals plus or minus the square root of 75. Now we reduce the radical before we do anything else. 75 is divisible by the perfect square 25. And 75 divided by 25 is 3. So that gives me plus or minus 5 square root of 3. Okay? Then we add the 7, and x equals, it's generally considered normal to put the non-radical portion first and the radical portion second, like so. Okay? So that was example 1. All right, here's a second example. Here, the LCD of 2 and 5 is 10. So we'll need to multiply everything by 10. That includes the x. Not that that's multiplication by 0 changes anything on the right side. So that's going to leave me 5. That's going to leave me 2. So I have 15x squared plus 10x plus 8 equals 0. I can't take the 15 out, so it's not of everything, so it's not easily factorable. It's not conducive to completing the square. So as I said, you can't take the 15 out, so you can't. It's not conducive to completing the square or the factoring. So we're going to do that. So x equals. So let me go ahead and fill in what these are. A is 15, B is 10, C is 8. So x equals negative 10 plus or minus square root of 10 squared minus 4 times 15 times 8 all over 2 times 15. So first, under the radical. So my first thing I do is what's under the radical. Ten squared minus 4 times 15 times 8. So that's going to be 100 minus 480, which gives me negative 380. Second, square root of negative 380. I'm going to factor out the square root of negative 1 as a positive I. And 380 is divisible by the perfect square 4. Okay, so that's got to be 2 times I, square root of 95. So third, x equals negative 10 plus or minus 2I, square root of 95, all over the 30. I'm going to split the fraction, then reduce. Negative 10 over 30 plus or minus 2I square root of 95 over 30. So x equals, when I reduce, this is going to be negative 1/3 plus or minus I over 15 square root of 95. All right. All right, here's a third example. The least common denominator between 7 and 21 is 21. So we'll be taking 21 times 1/7 x squared minus 21 times 8/7 x equals 21 times 20 21st. Cancel. 21 divided by 7 is 3. 21 divided by 7 is 3. And 21 divided by 21 is 20. So that gives me 3x squared minus 24x equals 20. Okay, we're going to bring the non-quadratic side to 0. So I have 3x squared minus 24x minus 20 equals 0. Okay, I cannot take the 3 out of everything. The 3 goes to the 3 and the negative 24, but not the 20, negative 20. So it's not easily factorable to me, and it's not conducive to completing the square. So I'm going to do that again, the quadratic formula. A is 3, B is negative 24, and C is negative 20. So x equals negative 24 plus or minus the square root of negative 24 squared minus 4 times a 3 times a negative 20 all over 2 times a 3. First, under the radical, I take what's under the radical out separately and work on it separately. Okay, I apologize about this falling down. I'll get it back up there. Hopefully it'll stay this time. Okay, so I don't remember off the top of my head what 24 squared is. Negative 24 squared, negative 24 squared. It's got to be the same. 576. There's actually 2 minuses here, so this will be a plus. Okay, 240 gives me 816. Okay, second square root of 816. Okay, I'm going to try 4 because it's even. So 816 divided by 4 is, 204. 204 is divisible by 4, so I didn't go high enough. So 816 divided by 9. Nope. Fraction, mixed number, whatever. Okay, this is what it looks like in decimal form. Okay, so now I'll try 816 by 16. I get 51. And 51 is not divisible by any number on that list. Okay, so it's got to be 800, so it's going to be 16 and square root of 51. Square root of 16 is 4. Okay, so that's 4 square root of 51. Third, x equals positive 24 plus or minus 4 square root of 51 over 6, which splits up as 24 over 6 plus or minus 4 square root of 51 over 6, which reduces as 4 plus or minus 2 over 3, the square root of 51 in the numerator. Okay, the board will look different from the previous examples because I redid this example from the first draft of the video. So here it goes. First, you're going to factor your denominators. That's factorable as a difference of squares. X plus 3, x minus 3. I could factor an x out of these two terms. That gives me x squared minus 9, which further factors as x plus 3, x minus 3. And because this denominator has all the other denominator factors as factors, that makes it the LCD. Next, we worry about excluded values. These are the values that make the denominator equal 0, and therefore x cannot equal them. So we can let the LCD take care of that. So x cannot equal 0, x plus 3 cannot equal 0, x minus 3 cannot equal 0. So subtract your 3 x cannot equal -3. Add your 3, x cannot equal 3. Next, we will clear our fractions using the LCD. Use factored form for your denominators. That'll be 7x plus 5 over x plus 3, x minus 3, times the x plus 3, x minus 3, equals 2 over x plus 3 times x plus 3, x minus 3, plus 12 over x plus 3, x minus 3, x plus 3, x minus 3. So, cancel away your denominators. The x plus 3's cancel, the x minus 3 cancels here. Here, just the x plus 3's cancel, and here, everything cancels. Leaving me. Well, what I'm going to do is I'm going to try to do this as few steps as possible, because again, space is a premium. So this x would actually be multiplied against both terms in the numerator. Okay? Over here, you would have 2x times x minus 3. And then plus 12. So, I have 7x squared plus 5x equals 2x squared minus 6x plus 12. All right? So I'm going to move this up here. Seven x squared plus 5x equals 2x squared minus 6x plus 12. I need to make one side, I need to bring all the quadratic terms to one side. So I will do that first. And I end up with 5x squared plus 5x. Okay, well, I'm going to need to bring all, to make this possibly doable by the quadratic formula or by factoring, then what I need to do is I need to actually bring everything over here to the other side to make this 0. So now I have 5x squared plus 11x minus 12 equals 0. Now to me, this is not easily factorable, because I can't take the 5 out of all the terms. So to me, I would not consider this not easily factorable. I consider this not easily factorable. So I'd use the quadratic formula with a equals 5, b equals 11, and c equals -12. All right, so x equals -11 plus or minus the square root of 11 squared minus 4 times 5 times -12 all over 2 times the 5. I always do what's under the radical first, under the radical. So that's 11 squared minus 4 times 5 times -12. Okay, let's see what that looks like on camera before I go any further. It's not really that legible. Let me try it again. Okay, so this is 121. There's actually 2 minuses in this multiplication. So it's actually going to be adding 240, which gives me 361. Second, The square root of 361 is plain and simple 19. Okay? Third, x equals negative 11 plus or minus 19 over 10. So, I have negative 11 minus 19 over 10, or negative 11 plus 19 over 10. Okay? Because I can add and subtract those. There's no I, there's no radical there, so I actually have to do the additions and subtractions. So that's negative 30 over 10, which is negative 3. And this is 8 over 10, which is 4/5. Now, it's important, having gotten these, that we check them against the excluded value list, because negative 3 is excluded. So the only solution is x equals 4/5. Okay, I'll try to write that more legibly. X equals 4/5 and 4/5 only. All right. All right, so here's another example. First, distribute this x through. So I'll have 21x squared plus 17x equals 104. Bring one side to 0. 21x squared plus 17x minus 104 equals 0. Now, because I can't take a 21 out of everything, it's not going to be easily factorable to me, and it's not conducive to completing the square. So A will be 21, B is 17, C is negative 104. So x will equal, per the quadratic formula, negative 17 plus or minus 17 squared minus 4 times 21 times negative 104, all over 2 times 1. Sorry, 2 times 42. 2 times 21. Force of habit, sorry. Okay, so first, under the radical, 17 squared minus 4 times 21 times negative 104. That's going to give me 289 plus, because there's 2 minuses there, so that's going to be a plus, 8736, which I believe will give me 9,025. Okay? Second, square root of 9,025 is just 95. So third, x equals negative 17 plus or minus 95 over 42. So because there's no I, there's no radical, these are combinable. Or negative 17 plus 95 over 42. So negative 17 minus 95 is negative 112 over 42, which, and this is going to be, this reduces to negative 14/3. This was 78 over 42. Both of these are divisible by 2, so this gives me, they're also divisible by 6. That gives me 13/7. So x equals negative 14/3 and 13/7. All right. Okay, here's another one. Here's another example. X times x minus 3 is negative 73 fourths. Do. First of all, we're going to distribute this as x squared minus 3x equals negative 73 fourths. Next, the LCD is 4. So we'll have 4x squared minus 4 times 3x equals 4 times negative 73 fourths. So the 4's will cancel, leaving me 4x squared minus 12x equals negative 73. I'm going to bring this 73 to one side, or to the quadratic side, so that the other side is 0. Okay, now I can take a 4 out of the 4 and 12, but not the 73. So it's not easily factorable. I can't take the 4 out of all 3. These two, yes. This one, no. So it's not conducive to factoring, and I wouldn't bother completing the square. Okay? So A is 4, B is negative 12, and C is 73. So x equals, per the quadratic formula, negative 12 plus or minus the square root of negative 12 squared minus 4 times 73. And that's a 4 over 2 times 4. Okay? That's an ugly looking line. I'm going to try this again. Negative 12 over 2 times 4. First, under the radical. That's the first thing I do. So that's going to be negative 12 squared minus 4 times 73. So that's 144 minus, because there's only one minus, 16 times 73 is 1,168. So 4 times 4 times 73. Yeah, and then 144 minus that is negative 1,024. Second, square root of negative 1,024 is I square root of 1,024. And the square root of 1,024 is 32i. 32 times I. Okay? You can have situations like that. They happen. So third, x equals positive 12 plus or minus 32i over 8. I'm going to split that up into x equals 12/8 plus or minus 32i over 8. So x equals, this reduces to 3/2 plus or minus 4i.